So, good day and welcome to the Society for Ethnobotany's Student Café. My name is Hannah Reid Ford, and I'm a member of the Society for Ethnobotany Student Committee, which organizes events like this one. And for anyone in our audience who's not currently a member of the Society for Ethnobotany, or SEB, the mission of our organization is to foster and encourage scientific research, education, and related activities on the past, present, and future uses of plants and the relationship between plants and people, and to make the results of such research available to the scientific community and the general public through meetings and publications. Our student membership is open to both undergraduate and graduate students interested in ethnobotany, ethnoecology, economic botany, or any other related fields who are official members of the Society. And some advantages of becoming a member include an online subscription to our quarterly journal, Economic Botany, eligibility to submit manuscripts to Economic Botany, invitations to members-only events, eligibility for grants and awards in support of student research, access to our Plants and People online newsletter, and invitation to and the opportunity to present papers at our annual meeting. And without further ado, I'd like to introduce you to today's presenter, Dr. Jonathan Dombrosky. Dr. Dombrosky is an environmental archaeologist at the Crow Canyon Archaeological Center, where he uses big data to answer broad questions about subsistence practices and zooarchaeology in the central Mesa Verde region. Some of his major projects have focused on ancestral Pueblo fishing strategies in the middle Rio Grande region of New Mexico during the late pre-Hispanic period. And his wide-ranging interests include human behavioral ecology, stable isotope ecology, 3D geometric morphometrics, radiocarbon chronology building, and conservation biology. And today he's going to be speaking to us about his professional journey, his interest in data science, and some key takeaways and best practices for student ethnobiologists before opening up to a question and answer session. So please do keep your microphones muted until we get to the Q&A session, but feel free to use the chat function throughout, and I'll be monitoring the chat function so that if anything does come up that seems like a really interesting point or question, Jonathan can address it during his talk. So without further ado, pass on to you.
Awesome. Let me share my screen here. Is that coming through, Hannah? Fantastic. Let me move you around really quick. Okay. All right. Well, thank you so much, Hannah, for inviting me to do this. I'm actually really excited to talk about this kind of journey that I've had with data and data science. It's something that now in my professional career, I just think about all the time. I kind of live, eat, and breathe this stuff. And I really like talking with students about this skill because I feel like um, where I'm at now versus where I began in terms of data science specifically, I now feel like I kind of have almost a superpower. And that's a really nice feeling to have. And I always just want to instill this kind of superpower in anyone that is interested. So thank you for giving me the space to talk about this. So first things first is I just want to say that I am not necessarily an ethnobotanist by training. I am an ethnobiologist. I am interested in ethnobotany, that's for sure. And actually, and different things like stable isotopes and integrating zooarchaeological data with paleo-ethnobotanical data. And so my kind of career when I was a student, undergraduate, master's student, I'm really interested in analyzing kind of bone specimens like these that you see, a bunch of fish bone fragments from archaeological sites. This is where I started. And so I'm just going to kind of give you the kind of domain kind of interests that I have to get, and we're going to get to thinking about data and where that kind of took me. So first, I was really just interested in how we think about ecosystems in general and ecosystem change or disturbance, if that's really the lingo that you want to use, and how we think about that obviously through time. And so this is just a really nice graph that I like to kind of demonstrate these things. Normally, when we think about ecosystem change, I'd say like, you know, the more popular views are that when people come into ecosystems that they then disturb, ecologists might use this word, hardcore ecologists, disturb ecosystems. So in the case of the first Americans in, you know, North America, we would see that the actual trajectory of change when people came into these ecosystems, it also drastically changed. And then maybe even more change with, the, say, the arrival of Euro-Americans. But really, we know when we think about change in ecosystems that it's far more dynamic than that. That actually disturbance is probably not the best way to put this all the time. Um, More change, and that change itself, original ecosystems, if you want to call them that, um, they actually have their own fluctuations as well. So if we're especially wanting to conserve to different time periods, I got interested in, okay, what are those time periods and why? How do we make these arguments? With different animals, let's say. And so my initial kind of research had to do with freshwater ecosystems in the desert. So this is, New Mexico. And I really started here. Let me get my pointer here. Really started getting interested in, see if I can find that pointer. Can I? Yes. Um, the upper Rio Grande region here, and then my dissertation work took me to the middle Rio Grande over here, which is where Albuquerque is today. But I got really interested in this fish right here called the blue sucker, and that it actually occurred farther north in the Rio Grande when its actual populations in the Southwest are thought to only have occurred at this time in here in the Pecos River. It was never thought to have been this far north by conservation biologists, and this is kind of a very threatened species due to a number of different ecological tolerances that it has. And so what I did some work finding archaeological sites from this area that showed that indeed this fish was present and that actually we should think about range reduction very differently and actually areas of maybe even potential reintroduction very differently. So that's how I got into this. And then for my dissertation work, I really extended this kind of thinking about fishing, ancestral Pueblo fishing in the Middle Rio Grande region by reconstructing food webs, hence now understanding, actual ecosystems a little more wholly, not just with the animals, but also plants and things like that, primary producers. And then also really interested in biometry. So calculating, body size from fragments of bone, how do we do that? And developing some kind of new techniques for that. So that was really just a quick introduction to kind of me in terms of domain-specific knowledge. But now I kind of want to turn to, okay, well, given all those things that you're interested in, okay, why are you now obsessed in talking to us about data science? And so first off, we should maybe talk about, what data science is. And I think this kind of Venn diagram is really nice to think about that. Data science is definitely a term that is thrown around a lot, and we're not so sure all the time, what exactly it means. Um, so is this, Hannah, is this coming through? Can everyone see this, or is it still on the same slide?
No, no, it's coming through.
Okay, the Venn diagram's coming through. It's all messed up on my end. Anyway, there we go. So data science is the intersection, and this is Drew Conway's Venn diagram. It's not mine. I did not make it. Is the intersection of hacking skills, and this is kind of tongue in cheek here. It's not necessarily hacking skills. It's coding skills. Okay. This is just to be a little silly. It's kind of coding skills or hacking skills, if you really want to call it that. Math and statistics knowledge. And then your domain specific knowledge. So in this case, ethnobotany or ethnobiology or zooarchaeology or whatever, right? It's the overlap of all three of those things, and the intersection is data science. Um, Typically we would think, and especially when I was kind of when I was in my undergrad and master's, that domain specific knowledge and math and statistics knowledge, that's kind of your area of traditional research. Is there some kind of thing that you are analyzing? That analytical thing is what makes it that kind of research. But then as coding has become more popular and more of a necessity, and there's a really good reason for that, then we've kind of started getting into this area of data science. um, the other thing here is that I really think it's important to point out this danger zone of what Drew Conway calls when coding skills, your ability just to code something, and your domain-specific knowledge overlap. If you only have those two, that's called the danger zone, because that's when you can start making you can be really fast and loose with data. You have to pair that intersection with math and stats knowledge, and that's when it becomes valid data science, right? You're not just shooting from the hip and making things up with code, right? So you have to have all of these things. So my interest in this, obviously, I kind of come from more of a quantitative side of things, given all my interest that you saw before. And I got more and more serious, I would say, about how I actually think about data. What are the practices that I use to document the things that I actually say that I think are going on with my research? Um, and I was, this whole time I was kind of not really being, I would say, by my mentors, which is not their fault, really not necessarily being encouraged all the time to get into coding. I had a really strong math and stats background by taking some classes and being very serious about knowing that. I was not originally good at math and stats, especially in high school. I was terrible, actually. But I knew it was a gap and I focused on it a lot. And so took courses in this. And then, was pairing it with my interests. But, no one necessarily in the early days was pushing me to do coding or anything like that. And it wasn't until I started kind of I was needing some, newer tools in my research that I had to code. I had to figure out how to code to use like, I would say up to the minute methods. So that's how I got into it. And initially, my journey, I was dipping my toe into this. I was not wanting to code really. I was doing everything that I could not to code because I just thought like, well, that's just too much for me. And that's not my path. And then as I got more into it and committed to a certain philosophy around data, it's not until that I just kind of skyrocketed, and now I think it is a superpower, and I want this superpower for everyone that I talk to, if they are interested and they want it to. Any things that have come up in the chat here? Just want to take a time. No?
Not yet.
Okay. So that's a little bit of the journey. And when I think about the tools that I use kind of on a day-to-day basis, we can kind of discuss those and what those are. I think this is an area that is really daunting when you're first getting started. There are so many tools. There are a lot of programming languages themselves. So picking one and then the right tools within that, it's really hard initially, and I don't think that any of this is easy, by the way. I don't think, the superpower is not learning it all immediately. It's a little bit of an uphill battle. The learning curve is steep, but when you kind of dedicate yourself to this, there's a lot. So hopefully some of the stuff that I can talk about will kind of give some perspective, kind of a whole picture perspective of the kind of tools that are out there. So I use the R programming language the most. The R programming language is an open source extension of the S programming language. S programming language was at the time that R was created was semi-proprietary, and then R came about because it went full on proprietary, and there needed to be an open, free source of that statistical programming language. R was developed by two professors in New Zealand in the early 90s, around 1993-ish. And so R was just kind of floating around kind of different areas. A lot of the S users knew about it, kind of floating around for a while, but it was first officially version 1.0.0 was released in 2000. And then since then, the community of R users, I would say, has exploded. There are lots of R users, and I think it's for a very good reason. But so I start off in R. I use some other programming languages. Another very common one is Python, especially if you do geospatial work. Python is really good, or machine learning work. But R is really nice for academics, especially because of how good it is at statistical programming, at statistical testing, those kinds of things, the kinds of things that we want to do all the time. This language was designed to do. So why a hardcore coder who's trying to build web pages or all kinds of different applications, they might not like R so much because it's not very, I guess the word is extensible, or maybe even interoperable, but it's really good at statistics, okay? And it can be extended into many different areas, especially since the community has kind of exploded. So R is my first kind of language, and then there are other languages surrounding databases, um, and then other things like Python. So we'll talk about those a little bit. But for most of this time that we're talking today, I'm going to show you some kind of things in R. And again, if anything comes up, please interrupt. I can yap about this stuff. So R is all well and good. You can go to the website where R programming in Google and download this very easily. And then how I interact with R is through what's called an IDE, an integrated data environment called R Studio. I'll show you this today a little bit, maybe even do like a little quick tour. But basically, it is just a little portal with which to access the R programming language. That's really nice for people that want to do kind of larger projects. It's got all kinds of bells and whistles that help you stay organized and that kind of have all kinds of different file interactions. It's really great. I can't imagine my life without RStudio. Within the last few, actually, year or two, the company that has created RStudio is called Posit. They used to be called RStudio, but the company now changed their name to Posit because they want to use all kinds of different programming languages, not only R. They wanted to get multivocal, I guess is how you could say that, or multilingual. And they've developed a new IDE called Positron. And Positron kind of has a little bit of a different feel to it. I've been using it these last few kind of weeks. Um, but for more traditional coders, this is a really nice environment to work with. But still, I think RStudio, because I'm using R so much, for really hardcore R users, RStudio is still the kind of way to go. But if you're coming here with a maybe different coding background, you should look into Positron. So again, these are just programs where you interface and actually use a programming language kind of in your day-to-day work. Okay, now when you see these tiles, I'm going to be talking about packages, which are essentially little tools that you download within R to do work for you. And so when you see this little tile shape, that's kind of what's happening there. It's something you download within R to do some work for you. Basically, people write all these kinds of functions and programs out so you don't have to. And they do really great things and they document them really well. One of them that I use all the time is called Quarto. Quarto actually it's a package that comes with RStudio when you download it. And the reason why I use this one so much, it's relatively newer. This is a one-stop shop for scientific publication. What this means, what I'm kind of saying here, and I'll maybe show some examples of this, is that you can go from your code, the thing that you did to generate some results or a graph or something like that, and you could actually have a fully formatted publication if you wanted to out of this tool. It can move between the heart of this is something called Pandoc that the engine behind here, it moves between all file types, or not all, but an incredible amount. So essentially what I can do is I can have one document where I have my coding project and say a report or something like that. And I can create a PDF fully formatted, references, everything like that. And then I can move that document seamlessly to a PowerPoint presentation or a Word doc or all kinds of different file types. It's pretty amazing. The punchline here is that I never have to remember how I generated results or graphs or anything like that because the code is behind everything. And we'll talk about this and why this is important with documentation. So Quarto is amazing, is really the real point here, and I use it all the time. They all have websites here. So I think it's quarto.org, or you could just, Quarto R Publishing, and you'll find it in Google. The other tool package that I use is called the Tidyverse. And this is how Hannah and I met. I have taught workshops on how to use different packages within the Tidyverse. And it's really a meta package. And I would say this, if people are jealous of our users, It's because we have the tidyverse. And all the tidyverse is, like I said, it's a meta package, and I'll talk about sub packages within this. When you load this into the R environment, a bunch of different tools come out. Um, they are all these packages that work almost seamlessly with each other. They have the same philosophy of how to use data. And so you can do really advanced things, really basic to really advanced things in the same way. And it's just really great. So yeah, I saw some things coming into the chat. Any questions?
That's just me. I'm popping in some of the links that you've been talking about
Oh,
into the
thank you,
chat for
Hannah.
everybody.
You're the best. Thank you. This is really great. Um, So yeah, the tidyverse makes other programmers and statistical programmers, especially those using Python, which works and is good and better than R in some circumstances. But the tidyverse definitely will make people jealous. And the reason that is because the entire kind of data workflow is supported by the tidyverse. And I have basically a little kind of schematic here that simplifies what I'm talking about when I say data workflow. I mean the ability to import data, then to make that data really nice and easy to work with, there are packages that support that within the tidyverse. Then there are tons of packages that allow you to manipulate your data, to summarize it up in different ways, to create new things, all kinds of different things, to basically get those insights that you're looking for, to take that new data set, that summarized data set or transformed data set or whatever, we call that wrangling. Then we can take that and maybe even do some modeling or programming with it. There's a really great package called Purr that allows you to do iteration and things like that. And then we can have some really great insights from that and then visualize those things with ggplot2. ggplot is also really, really kind of famous package for tons of for data visualization, essentially. But then you can go beyond and actually communicate data as well with this. I showed you with Quarto. So it supports this entire kind of the thing that usually academics need to do all the way through, which is really great. So I use these packages daily. There's a really important new package that I use quite a lot if you get into machine learning or predictive modeling or anything like that. That's called tidy models. In Python, they have PyTorch, which is the main one is really well known. Python's very good for machine learning, but and it used to be people said, well, you can't do the kinds of machine learning that you can do in Python, and that was until tidy models kind of came out. And this is another meta package. There are sub packages that were developed for this, and it is just mind-boggling what you can do with tidy models. I won't get into all of it because I won't stop, but amazing tool. What's wonderful about the R programming language or just open source kind of data science languages or packages or things like that, just the community also in general, is that it has really great support. There's actually so much support that it scares people when they start getting into all of this. They Google something and there's stuff everywhere, and then you start getting overwhelmed. And I wanted to provide these two books to they really cut through all of that. And if you can work through, especially this one first, the R for Data Science second edition one, the second edition is great. You are good to go. This is a wonderful book. It teaches you the whole picture of how to use R and the tidyverse, not just kind of dipping your toe in, using one tool and then getting out of R, to use it to its full potential. And it is free at this URL here. That's really great as well, right? With open source, folks, for the most part, all of these resources are free to use. And it's really nice. So I have my copy here that is well worn, but so you can get actual physical copies of these. But you can go online and work through this in R and figure out this superpower. So yeah, if you work through this entire book, I promise you would be ahead of most people that can program in your field. Most, I don't say all, but most. Um, the other one is the tidy modeling with R, which is all about that tidy models meta package. So if you're interested in AI and machine learning and actually how to implement these tools with the projects that you're working on, not just use ChatGPT, but actually generate a predictive model on your own, this is the package for you. And this is the book that kind of teaches you how to work with that. It's more advanced, undoubtedly. You have to start here if you don't already know. But working with this package is really, really great. So yeah, two main books definitely to use in terms of tools. The other one that I use all the time, which is also in the tidyverse, is a database tool, dbplyr, is what this is called, or Plier. And it's basically how to use a true database, which we might talk about towards the end, within R. So I'm not talking about just a spreadsheet, right? One table of data, but actually a database. Maybe you could create an access. There are other ways to link to a database and manipulate data, summarize it, and get it into workable, fashion to actually analyze things and report on them, etc. I use this one a lot. At Crow Canyon, where I work, which is a nonprofit in Southwest Colorado, this is kind of the core of our database, kind of giving you a visualization for it. Um, each one of these nodes is a table, a spreadsheet that we have from archaeological sites that we've worked on for about 40 years worth of data in this database. It's a lot. We've collected data from the field in roughly the same way, and it can be linked across many different data sets or tables. So let's see, let's look at it. We have basically table PD right here is all the provenience information when people are out in the field, um, associated with different contexts that are being excavated, every level essentially. And there's spatial information associated with that. And then there's table pottery, which has all the pottery that has been analyzed ever, and it can be linked back to the exact coordinates that where that came from, which is then associated, in table PD, and then exactly what kind of soil was in there, the depth, all of that information. So basically, complex tables that can be interlinked with one another. Hannah, is these little lines, are they coming through? They're really fine. I don't know if people are seeing them. So
Yeah, they
yeah,
are.
okay, the lines here, what these represent, this kind of mess that you see here, is all of the different fields or like basically columns of data that can be linked to other things across the database. So it forms a network. Okay. This means that you can move from, say, this table all the way across to different tables and interlink things in novel ways, right? This is what a database is. If you ever think to yourself, do I need to use just a spreadsheet or do I need to use a database? You need to think to yourself, do I need specific information stored in one way for one thing and then another way for a different thing? And can I link them together? And if the answer is yes, then you need a database. Another way to frame that is if you have to record basically within one spreadsheet data on one line for one reason, and then you go to a second line and it has to do with that previous observation, but you're recording different data in a different way, you need a database. You're essentially repeating data is my point, and you need to break it out. And there's all kinds of stuff about database regularization that you can learn about for that. But databases are important, and you can work with them in R and in different programming languages. There's tons that you can do. So. All right. Hannah had also asked me to talk a little bit about challenges and opportunities, and so I'll try to kind of get through this a little bit fast so we have tons of room for questions and things like that. So the first one, I always talk about this when I get a chance, is the first kind of challenge that I see is breaking culture around the idea of reproducibility and what research does in our fields of interests. So these are results from Nature's reproducibility survey from 2017. So it's kind of getting a little old at this point. But basically what they did was surveyed a bunch of people that published in the journal in the last like from then 5 years or so, and they got about 480 respondents for this. So N for this is 480. And they asked them a bunch of different questions. One of which is which factors contribute to the failure to reproduce results. This is kind of when I would say the reproducibility crisis in the sciences and social sciences kind of reached its peak in terms of people really taking this seriously. And scientists themselves, okay, the punchline here is scientists themselves um, cited the selective reporting of results as the main reason for the reproducibility crisis. Okay, so what does that mean? At least when I think about the beginnings of my training, I can see it in there, this problem, the selective reporting of results. It is kind of subtly communicated to us in different ways. Perhaps you've had this experience too, that your sole job is to find novel results and then publish on them, right? You're supposed to find that really cool thing that no one's thought about, and that is the end goal of your work with whatever question you're associated with, right? In terms of your domain and your research trajectory and all of that. That is the goal. Has anyone had that experience? Um, I definitely did. So what that means is the selective reporting of results. You get a really cool result, cool graph, cool statistical thing, whatever, and that's the thing that you're reporting on. That's a problem because that's really, in my view, my opinion, that's really not your job. Your job is to find that really cool result, right? And then you need to document how you interrogated that result. How do you know that that is indeed true, right? Documenting that process through time, slowly and incrementally, is what coding, programming language is all about, the process of documentation in different ways and being able to reproduce what you did a year ago on that project that you're working with and then pick it up and move forward and then share that with other people. So basically, what this is saying is failure to reproduce stuff is that we are working on the wrong thing. Okay. And I can expand more on this if this is a little unclear. Okay. So I want to talk about these acronyms that you will certainly see, or if you have not already seen them in terms of challenges and opportunities, and they are related to data. The first one are what are called the FAIR data principles. And this is just an acronym that stands for findable. So data must be findable. Getting these principles out into the field and in practice is kind of the big opportunity right now. You'll see these everywhere. So data must be findable. And what I mean by that is if you're working on something, people should be able to find that data that you have some result associated with. Not only should you be able to find it, but that data should be accessible in some way. Now, this does not mean that all of your data has to be shared, okay? That's not what this means. That this means that your data or the metadata associated with it should be accessible in some way, or that if you have sensitive data, there is a process of governance that has been implemented into the workflow associated with your work. Essentially, if someone at the end of the day must had to reproduce your work, it can be done. There is some way for that to happen. It cannot be hidden. Okay? So there is someone who can check your work theoretically. Okay? The other thing here is that things must be interoperable. Data must be interoperable. The data, if it's only coming from proprietary software and only works in something that costs tens of thousands of dollars, it's not very useful to the research community. Your data has to work in many different areas, and especially in open source environments like R or Python or something like that. And then your data should be reusable. And really, this one just has to do with that your metadata or how you have kept track of that data aids in how people can reuse it, that people know what your data is actually all about. Usually, this comes in with a really good README file. But these are all kind of interrelated, and we can talk more about them. The important challenge and opportunity with all this is, yes, we want our data to be more open, more easy and accessible to use, but we cannot forget, especially about of those of us working with indigenous communities or with indigenous data at all, that there are some real ethical standards that need to be implemented. So the FAIR principles need to be linked to ethical standards, and these have become the CARE principles. And this is the paper by Carroll et al. That really cemented these CARE principles. And I'm going to talk about them really quick here. Basically, data, if you're gonna work on fair data, you should design projects to have collective benefit for the indigenous groups that are associated with that data. Okay, from first and foremost. Otherwise, why, if you are collecting data that has immediate harms, then you should be asking yourself, why are you collecting that data? And why is it fair? Really fair. Um, the other one is you should lead with those indigenous groups or communities or individuals. You should give them the authority to control that data, to lead with. That is not always feasible. It sometimes can't happen in certain circumstances. And that's why the next one is so important, which is you should be thinking about responsibility associated with that data the entire time. What is your responsibility so that you minimize harm and are working with people collaboratively? And then obviously within that, ethics never leave this process. So you could unfairly, I would say, criticize the FAIR principles as like, all data should be open data practices. And the CARE principles really put that in check. Those who really think about fair data, though, they would never say that ethics are not part of that. But it just underscores how important the CARE principles are. So my perspective on the role of data science and ethnobiology is, when we think about documentable, clear, reproducible things, we have a obligation, an ethical obligation. If you're working with indigenous data, an ethical obligation to ensure that it is reproducible, that you cannot forget what you did, and that you can communicate it clearly with others so that nothing is lost in the process. It's imperative, is another way to sum up what I just said. Um, so let me go through some just key takeaways. The first two here are really practical. We can talk about the knowing your file structure, where files are, how they are saved on your computer is a must. It's the first thing that you should do. Knowing when to use spreadsheets versus databases is really important. We talked about that a little bit before. Again, simple one spreadsheet, one table, and then interlinked tables. Usually, I would say, PhD level projects, you probably need a database. Some other things in terms of getting started with programming languages or coding or just data science, you should start now. Okay, don't hold it off. It's like exercise, it's starting now will be better than later. Oh, this kind of got all overlapped. Here, I will talk really quick about this thing called the pit of success. Um, so one of the things that you should be is flexible. And when I say this, when I talk to people that get frustrated with coding, they get really upset with coding because it is inflexible. It constantly gives you error messages and it is tough. I'm not trying to minimize that feeling, but its job, the computer's job, is to be inflexible, which means that you have to be flexible. This is known as the kind of pit of success, which is basically this idea that the thing that you're working with, in computationally speaking, should force you into good practices with whatever its job is, right? So it's not necessarily like a mountain that you climb and then you, after so many arduous victories, you finally hit the peak of learning about R or whatever, or coding or data science. That's not it. It's that you essentially have just leapt into something that you can't escape, and it's going to force you into working as best as you possibly can with data. So that means working with a pretty inflexible thing sometimes. So it's your job to be flexible. It's a very humbling experience. Um, you should commit to it. I started with just putting my toe into it and thinking I could only code just a little bit. It was a waste of time, and I was tricking myself. Commit to all the things that you can do, and then the superpower will be unlocked. Start small. Obviously, that makes sense. Bite-sized pieces. Read that book. and then seek to collaborate with, and I mean that very generally, with indigenous communities, individual scholars, but also about your data, but also with other people that are maybe domain experts in different areas. And so that you can maybe show off your skills and what you could bring, what the fair and care principles can bring to the table. So that's it, and we can open it up for questions.
Thanks so much, Jonathan. Really, really appreciate that. I'm
Yeah.
going to start off with a question that came into the chat because, as I recall, when I did the R programming workshop with you in Nevada, this was my exact question. We were getting
Ooh.
into, what to do with the data, and I was like, but where do I put the data? So the question from Luna is, what about inputting and storing data? Are there any good tools that we can use to ensure that users input data into the database without any mistakes? E.g., a form
Mm.
of sorts that automatically updates the database, checks whether the input is in the correct format or not? And would you recommend any specific platform where we could store our database? Spreadsheet is really not doing the job anymore, but we need something easy enough for non-programmers. It's like my verbatim questions.
Oh, easy enough. So the caveat here is um, for non-programmers, I don't have a good recommendation, and I'm sorry. I'm sorry about that. The best thing that I could say in terms of if you want a fully functional, just really good database is look into something like PostgreSQL, a SQL database of some kind. But it is a programming language and you will have to build it. Or you can take an existing database, like one that was built in Access, and get it exported into a stable PostgreSQL database on a server somewhere. Your computer can act as a server, or if it's a really, really big database, you can actually get servers. I'm sure, universities in different areas have those. But anyway, um, so I don't have a good solution essentially for non-programmers. This is why right now you gotta make that leap. You gotta jump into the pit is my kind of advice here. Um, I know that's probably not what everyone wants to hear. In terms of how people, the forms that they use. So here at Crow Canyon, for instance, you can build literal forms. I don't know what you mean by forms. Maybe you mean this, but that actually, things that are like drop down have selections in them or things that you can write. And then they automatically get input into that database. So here we have that. When we're in the lab working with people, different people, it's a form that we're filling out the entire time. They're not working in a spreadsheet. Um, and so, but it automatically populates the database, our larger database. I can work in a spreadsheet and then we can put it into the database too. There's both of those ways that can work. So you can develop those forms, and then the data quality check would have to be part of your workflow. Someone that would have to be their job is to look and make sure that it actually all aligns. It's part of the workflow. So you can't escape it. It has to be incorporated.
Luna's I mean, I know after I did your workshop, I did start using MS Access just from my
Sure.
work my work is and so far it's been okay, but I think Luna is asking about NocoDB or NOCODB, and if you have any
Huh.
familiarity with that.
I am not familiar with it. Let me check the link just to make sure that that is true. Yeah, I just have to say, given the kind of things that I just talked about, um, I would be hesitant to use this. Me, and I'm not trying to say this dogmatically with everyone. If this works for your use case, then you should absolutely use it. But as soon as I see sign up money associated with this, you run the risk, and you'd have to work with people with this group. You run the risk of locking your data away. If you are not in full control of it, which means understanding coding, it's the pit, man. You got to jump into it if you want to ensure that everything is, safe and you are in control of everything the entire time. So getting away from proprietary software is kind of my philosophy. I'm not saying that that's for everyone, though. Again, I don't want to be dogmatic about this, but does that make sense?
Yeah. Would it, does anyone else have any other questions? And you can feel free to unmute and ask your question as well.
Hey, can you hear me?
Yes.
Yeah.
Hi, Esther.
Hi, hello guys. Thank you for the presentation, Jonathan. It was so nice. And my question is, I've tried many times to learn R and Python online by myself, and it was so difficult. I didn't even think I could finish the whole course. So I wanted to know if there are some sites or a procedure or what you did to learn these softwares. Okay.
It's a really great question, Esther. Thank you very much for asking it. And it really plays into the kind of larger like trajectory and how I grew with it. So I can expand on that a little bit. Um, like I told you, I learned R initially just for one package that analyzed stable isotope data in a specific way, essentially drawing very fancy ellipses with data. I joke that I basically just draw really fancy circles for my career right now. But so that's what I did. I used one package and got out of R as fast as possible, right? So that's how I learned initially. Learning one package really well is kind of a good step within this, this. Um, but then I went forward. What really took my R knowledge to another level is I learned the ggplot package and worked through an entire book that I can find by Kieran Healy on data visualization. Let me find this. Worked through it myself, typed everything. He has the examples in this book. It's free to use. You can find it here. You just have to click on the menu and all the chapters will become available. Um, I copied the code as I was going and made sure it worked. And what that meant was making mistakes all the time in terms of you make a little mistake and it doesn't work, right? So I had to figure out and go through that process of debugging and really get through that whole I have to be flexible, not the machine kind of thing. And then I went forward from there after I wrote this entire book out. Then I went forward and started learning more. I would not do that in retrospect. In retrospect, I would get this book or go to the website and work through this entire book, chapter by chapter. Another really good thing for Luna about this book is that there is a chapter in here about how to link analytically, the analytical side of things through to a database, to like an actual database that is, coded yourself and stable, PostgreSQL, all kinds of different things. So it's not about database creation. It's how then once you have the database, how to link to it and analyze seamlessly. So it's within this book. That's what I would do. This thing is gold. They on the second edition, they put an actual educator. Her name is Mine. You can actually see her on the like the Posit website and like YouTube videos everywhere. She's an educator and specializes in how to communicate and get people to learn about coding. So it's that level of good. She's really great. Does that help?
Yeah. Thank you.
Um, can I go off on a tangent really quick, Hannah? I want to share my screen again. One of the things that I want to say is I want to just provide an example of what I mean by reproducible. Can everyone see this? Um, we're in our studio right now. And when I talk about reproducible, this is a paper that I'm working on right now. This is the actual repository that this is what it looks like. There's all kinds of files and stuff in here, but it's really nicely organized. If I don't say so myself, data is in its own little folder. The figures export into its own little folder. There's other things. But I'm all working with this within R. This is our studio. This is the script associated with my like all the analyses that are in this paper, which there's a lot, and I had to break them out into different tabs. But basically, when I talk about something that's reproducible, I'm talking about something that I can zip up. I could zip up this entire folder, pass it to someone that I'm working with, or someone that's reviewing the paper, or to the audience. They could unzip it, and then they could literally press a button and everything would reproduce on its own with how we're given how the data is stored, the raw data is stored, and everything like that. So what I'll show you is how that generally works. What we're going to see is that it loads these libraries, these little things that do work for us, and then I'm going to go through and it's going to replicate figure one, and I'm going to chase it as it's going to show you what's happening. But this is stable code that can be ran with a click of a button. So I'm going to click a little button here called Run All, and you're going to see little progress bars, and the code is literally running. It's running throughout here and producing graphs. So now I'm producing this theoretical figure one. Oh, it just reproduced. Exactly how to make it is documented in the code above. I'm going through, I'm making this box plot. It's going faster now than we can keep up, but all of these things are tracked and documented. And this is what I mean by reproducible code. This is when your code is reproducible. Does that make sense to everyone? So these are the things that you can attach to supplemental figures or you can or supplemental files in like a publication or with a thesis or something like that that is stored in the repository for your university. This is what reproducibility is all about. From the rawest of raw data, how do you move to figures, visualizations, to summary stats, to inferential stats, to models that are predicting things? All of those things need to be documented, and the code gives that.
I think it helps to have these sort of conversations and to help us see what this actually means. I saw a joke
Yeah,
the other day that was like, um, what I'm an ecologist. And it's like, what does that mean? It means, and it said it means he's scared of R.
yeah,
And
yeah.
it was like that seems to be it seems like it's so daunting, but being
Yeah.
able to sort of, I know when you were when you did the workshop, seeing actually how these things ran and doing some of this work hands-on really, really helped with, okay, that's what that code actually does. And okay, yes, here are some little things that, you know, case sensitivity or, the order of things that you need to keep in mind. So, like for
Yeah.
Esther, I just want to say from my standpoint, I'm in the same position. I'm working through my online things. I'm looking at the books and it's still super daunting, but I think that's why these sort of interactions with people like you, Jonathan, are so helpful because it's like, okay, we can do this. We can
You,
we can overcome our fears.
You can absolutely do it. And it is like it's a lot. Again, I talk a lot with colleagues and some of my like, advisors and mentors. And they always tell me like, man, like you're on a different planet. And like I'm like, but I'm not. Like I know the actual like path that I took to get here and it is like achievable. So I do take that for granted sometimes. I do. But there is a path, starting small, small projects, being curious, and actually just when you see something going, how would I do that in R? How would I reproduce this figure? How would I do that? Like interacting with it all the time. Another thing on that point is it's not like all of a sudden, so where I'm at right now, this project that I'm working on, it's not like all of a sudden I don't run into errors anymore, right? I just don't run into the errors that I used to run into because now I know how they work and like how to spot them really fast. But you have to run into them to know about them, right? And it's that process of constantly being on the edge that can be really discouraging. But if you can be kind to yourself, right? Understand that you're learning something and have that mantra of like, I have to be the one who's flexible and patient because I'm trying to learn something new and engage with it, honestly, it will help. I don't want to say that, people we're trying to get, PhDs done, we're trying to get master's theses done, we're trying to get publications out. So everything feels so immediate. But if you learn this, you will have a superpower, again, that will stick with you for the rest of your career. That is the scale at which you're operating on. Um,
We have a question from Maria, and then
yeah.
afterwards there's one in the chat.
Hi, thank you for your presentation. I had a question, like I would like your suggestions about how to edit code because I have noticed that I am in a beginner process. So sometimes like I write like 4 lines, actually I can write 1 line for something. So I don't know how to work on that, how to improve that.
Maria, that is always the really hard part. So essentially, if I was you were a little muffled, so I want to make sure I got your question right. is how to make code more efficient. Yeah. Okay. So that's also learned. So you have to write the bad code to then write good code. And you learn all of those tricks that make things better. So for initially, if to just give you a really quick answer to this, I would say think about um, research programmatic or functional programming, I guess is the way to put this in fancy R speak, functional programming. What that means is the per package, learning about the per package and how it works, how to iterate effectively. That's where your efficiency lies. Is when your code, they say, this is a rule of thumb, that if you're writing more than 2 lines of code that is almost exactly the same, right? So 3 or more lines of code that are being redundant with each other, but just operating on a different part of your data set, then you know you need to edit your code. That's what they say. Do I totally stick to that? No, but you can theoretically learn functional programming to iterate more efficiently. And it's hard. To learning iteration is one of the main reasons to use computational approaches. Essentially, the ability to run the same thing thousands of times in the blink of an eye, right? And how to write program or functions that can do that really nice for your specific need is what I think you're talking about. And there are whole books on this. So like, it's not easy by any means, but learn about the wonders of purr is another way to put that.
And our question in the chat is from Kunyu, asking about any recommendations to learn data science other than self-taught community colleges or.
I would, working backwards now, I would say whatever your, domain specific research interests are, find the leaders in the field that are really on, committed to reproducibility and kind of data science and these kinds of things, find those people and then seek to work with them or see what they're doing. Are they doing workshops? Are they doing things like that at conferences? Are they writing books? So if there are classes that you can take, that would be really good. I would say, with community colleges, I'm sure there are fantastic courses, but since this community is so large, what you're gonna get is gonna be so tailored to that person, and it might be using coding language in a way that you would never use it. They might be, if you were just doing hardcore stats, they use R in a way different way. That's good to know, honestly, but like it's very different necessarily than using the tidyverse, for instance, which is all about human readability as best as you can with code. So I hope that helps. Work backwards from the leaders and try to find opportunities to work with them if you can do that. Otherwise, if it's at community colleges, then you can reach out to the professor and just say, hey, these are kind of my goals. Do you think this course would be good? That's all you would have. Hope that answers that question.
Does anyone else have any questions for Jonathan?
I just I didn't hear you mention the vegan package at all.
Oh.
And I didn't know if like you've found something that works better or it was just maybe just kind of implied. Like do you use vegan or is the
Yeah. So vegan is like for those maybe who not are not so don't know this, the vegan package is like the ecology meta package. There's all kinds of like traditional ecological things that are in the vegan package, like analytical approaches. And rarefaction is what I've used it most for. And so yes, I have used it. I would say that vegan is it doesn't all the time work very well with the tidyverse kind of syntax and philosophy. That's not to say that you can't force it. You can absolutely work with it in that. And I just haven't really gone back. I used it more in the beginning when I was learning things. And then I just kind of started coding my own versions of the things that vegan does as I learned more about the heart of that code, if that makes sense. So I implement it in different ways, or I try to build on it in different ways. But vegan is amazing. So I'm not trying to talk crap about the vegan package. It's a standard. You should, yeah, if that's your thing, then you should. There's all kinds of different ways to work with it. So vegan's great.
Yeah, and I don't think I'm at a point to be able to like code my own versions
Totally.
of these.
Sure.
The so the tidy models as well sounded, I hadn't heard of that. But we're a lab that does a lot of like machine learning models, like predictive modeling, like, and we've used mostly like R scripts before for like PLSR and that kind of thing.
Sure.
Is that, are those the type of things that you would recommend tidy models for as well? Or like, can you just say more about like what tidy models can offer?
Yeah, so Tiny Models is mind-blowing. The book, I mean, does the best job at introducing it, but it is only an introduction, and it's a hardcore introduction. Um, and so basically, when you now, how I think about this, right, is with predictive models, we're in a space with machine learning where it's not so much about using that one like algorithm, least squares regression or whatever, for the thing you're trying to predict, right? The category or the whatever you're trying to value. So if I'm trying to predict the body size for me, body size of a fish that existed in the past, right? There's not one way to do that. There are many ways to do that. A lot of different ways, actually. So what Tidy Models and PyTorch, what they're doing is they're allowing you to leverage all of these algorithms. And then within the algorithms, all the different bells and whistles, all the knobs that you can tune them with to go in of all the possible sampling universes of all the models that I'm interested in, which is the one that predicts my thing the best. That's what Tidy Models and PyTorch lets you do. So it's way different way of thinking. It's not selecting one algorithm or model type and then going, that's the best one, and I'm gonna go. It's evaluating what is the most optimal given all the options that I have at my fingertips. So it will include that kind of, I think you said PLS, Poisson least squares. Is that what you're talking about?
Partially squares.
Partial least squares.
Mhm.
So it'll include that. You can include that engine, that algorithm engine, but then you can race it against 20 others if you want and go, which one performs the best? And it provides a tidy framework to do all of that. It basically normalizes the inputs for things that are not normal. All these different models take things in different ways,
Mhm.
and then so that you can tune them programmatically, I guess. So learning to do that takes some time, but it's well worth it.
Thank you.
Yeah.
Any other questions? There is one question in the chat about the recording, and yes, the recording of the SEB Student Cafés will be available. We post all of the recordings for our student cafes to our website, so you'll be able to download the whole thing in, I would say, like a week or so. We'll post it to our channels.
If anyone ever wants to reach out or chat with me about stuff, I'm always open. I get pretty jazzed about this stuff. But there's just so much here, right, to work on. And it takes a community to do it. It's really important.
Any other questions?
Thanks for coming, Charlie.
All right, we might do my last call for questions. Okay, in that case, I'm going to say thank you so much, Jonathan, for your presentation. And thank you to everybody who was able to join us today for our October SEB Student Cafe. And if you're interested in becoming a member of SEB, we have financial aid available for students or for professionals from developing countries. And anyone interested in learning more can reach out to us directly by emailing seb@ethnobotany.org. And I'll put that link into the chat, that email. And I hope that everybody will stay tuned to our channels for upcoming presentations and upcoming events. And I'm going to stop the recording now.